So we're going to start on 5.5 with the law of sines. And we talked about yesterday sine A, which is the angle A, over side A, sine, which is equivalent to sine B over B, sine C over C, setting up as ratios, just all depending upon what is given. The problem comes with the law of sines. We use law of sines when we do not have a right triangle and we're trying to find angles and side measures that go along with that particular triangle. And the tricky part comes when we have a situation with angle side, okay? And again, this is kind of rated PG-13 with our language here today. And this only occurs if an angle and two sides are given. And this is just a little gimmick that we use to find out how many triangles, if any, will result giving that set of data. So we talked about that if side B isn't necessarily literally side B, it could be side A, it could be side C. It's the side where it does not have a given angle. So this random side multiplied by the sine of the angle that is given, if that measurement is less than the side that is given, then we end up with two triangles. Whoa. If that measurement is greater than the corresponding side that's given, we have no triangles, and if it's equal, then we have one triangle. And we use these measurements here. So in our particular situation, B is actually our little a here. Our sine A would actually be sine C here. And if we would multiply 17 times the sine of 36, we get 9.99. We compare that to the side that's given. 9.99 is greater than 9. So therefore we see if it's greater than, we do end up with no solution. And that is exactly what we found when we plugged that into the law of sines. No solution for our triangle. Okay? So, we are going to pick up today with our second example. And so flip your papers to the back side. And the first thing we're going to do is we're going to actually use that little gimmick to see how many triangles I'm going to have. Because if I look at this, I have that same situation, angle, side, side. Okay, same situation is resulting on this. So I'm going to, and that little gimmick that we saw yesterday only works with angle, side, side. So what I'm going to do is I see that C is my angle and my corresponding side. So I'm going to take 17 and I'm going to multiply that by the sine of 36. So I'm taking the side that is not corresponding with that angle. So this is the little loner. It's the lone side, okay? So on your calculator, you're going to take 17 times the sine of 36. And out of coincidence, it equals the same thing that the other one on the front side equaled as well, 9.99. So now that's all the calculating you have to do. The rest is a comparison. So I'm going to take 9.99 and I'm going to compare that with the corresponding side, 13. Is it greater than, less than, or equal? It's less than. So I look back here. It's less than. So how many triangles am I going to have? I'm going to have two triangles. And so that is the problem that we're going to be working today. So this results, so therefore, we're going to have two triangles. So that's what we're going to look at today, is how to find two different triangles given one set of data. Okay? And then when I'm finished videoing, I'm going to go back and show you with the little triangle-y things how that actually works. Okay? So, first triangle. I see here that I'm missing angle A, I'm missing angle B, and I'm missing side B. That's what I'm looking for. So that's my goal is to look for angle A, angle B, and side B. So I'm going to start out using my ratio of the angle and the side that are corresponding together. So I'm going to take the sine of 36, and I'm going to divide that by the side. So I'm going to take sine of angle C divided by side C. Set that equal. Since A is given, I'm going to look for angle A over 17. Okay? And then, using cross multiplication, take 17 times the sine of 36 equals 13 times the sine of A. I want A, so I'm going to divide both sides by 13. So on your calculator, and you can do that all in one step, and again, I said as far as rounding goes, it's probably best to wait for one-stop shopping to when you get it all into one fraction and dividing it out. And I got 0.769, rounding it to the thousandths. And is that my angle? Nope, because I have to take the inverse of that to actually get my A. And again, making sure that you're in degree mode, you get 50.26.
Why do you have to take the inverse?
Because I'm finding the angle measurement. I'm finding an A. So to find angle measurement, we have to use the inverse to get to that.
Okay.
Otherwise, you'd just be looking for a side length. Okay, so that's A, so that's 50.26. So I can fill that in for A. And then how do I find B given that? I can subtract. So my first step was finding A. Now my second step, I'm going to take 180 minus 36 minus 50.26. And angle B then is 93.74 degrees. And I just subtracted to find angle B. Since I have two angles that are found, I just take 180 minus both of those angles. And you get 93.74. Which leaves me with my side B still to find. So I go back to what I know, what was given originally with my very first ratio, the sine of C over the side C. So I'm going to take sine of 36 again over side 13. And then I'm going to set it up so that I can find my B. So I'm going to take the sine of my angle B over side B. Using cross multiplication, I get B times the sine of 36 equals 13 times the sine of 93.74. Divide by the sine of 36, divide by the sine of 36. B equals 22.07. So what we just did there is exactly what we did on the front page of the notes. Given a set of data, in this particular case it was one angle and two sides, we set up our ratios accordingly using cross multiplication and inverse sign if we're finding an angle, or just the simplifying as we did here for step 3 in order to find our side. Okay? Questions on that? So what we just did here is we found triangle 1. Okay, that's steps for triangle 1. Am I just zoomed in far or something? Why this isn't? Okay, now we're going to go to triangle 2. This will be the trickiest part of 5-5, but it's not bad. And just kind of stay with me on that. So again, we are still looking for angle A, we're looking for angle B, and we're looking for side B. Okay, those are still my unknowns. That's still what I need to find. Okay, those are still my unknowns. That's still what I need to find. And again, off video, I'm going to show you a manipulative to where I can show you these angles, and it might make just a little bit more sense. First step, I'm going to target angle A, just like what we did on the first step for triangle 1. And if you see, side A was given, but no angle. So that's why I'm going to target angle A. Okay, not just random. I'm going to pick angle A because side A was given. So what I'm going to do with that, I'm going to take angle A, or to find new angle A, I'm going to take 180 minus whatever the new angle I just found, 50.26. Okay? So I'm taking 180 minus that. Now, 50.26, let's go back to some geometry terms. Would that be an acute or an obtuse angle? 50.26. Acute, because it's less than 90. Because it's less than 90 to begin with, our second angle then that we're going to create is actually going to be an obtuse angle, which means it's going to be greater than 90. So by taking 180 minus this, it's going to create my obtuse angle. So 180 minus 50.26 results in 129.74. So that's my new angle A. So I get 129.74 degrees. New angle A. Now I've got it too small for you guys. Struggling with that today. Okay, so 180 minus whatever it was that we found for angle A, because I'm going from acute to an obtuse angle. Now, to find the new angle B, I'm doing exactly like what I did before. To find angle B, I'm taking 180 for a different reason. I'm taking 180 minus angle C that was given minus angle A that I just found. So I'm taking 180 minus 36 minus 129.74. And you're getting 14.26. And if you notice, angle B is going from obtuse to acute. So now I've got my new angle A, and now I've got my new angle B. And now all I need is side B. And I set this up exactly like what we did before, given our new angle measurements. I will stick with C, side C and angle C that was originally given. So I'm going to take, third step then, I'm going to take the sine of 36 over 13, and I'm looking for B, so I need angle B, the new angle B, sine of 14.26 over side B, that I don't know. Using my cross multiplication, B times the sine of 36 equals 13 times the sine of 14.26, which is my new angle B. Solving for B, divide both sides by the sine of 36. And so on your calculator, you're taking 13 times the sine, 14.26, making sure that's in parentheses, divided by the sine of 36. B equals 5.45. So once you get that written down, I'm going to step you through it one more time. Okay? So because we have one angle given and two sides originally given, we have that peculiar situation in which I could have three situations. No triangle, one triangle, or two triangles. We use our little gimmick by multiplying by the side that's not corresponding with the angle times the sine of that angle. And if it's greater than, we have a situation, less than, we have a situation, equal, we have a situation. Okay? So looking at our little gimmick, we determined with this set of data, we could have two triangles. The first triangle we used exactly like what we did before, where we did the sine of C over side C equals the sine of A, we don't know, over side A, and cross multiplying out, finding our different measurements and our angle measurements. But when we go to triangle 2 is when we have to do something a little bit different. We're still looking for angle A, we're still looking for angle B, and we're still looking for side B. But our steps just a little bit different. To find our new angle A, I don't set up a ratio. I'm going from an acute angle to an obtuse angle. How do I know that? Because the original angle was acute, so I know that the new angle is going to be opposite of that, which will be obtuse. And to find that, I just take 180 minus whatever my angle A was. So 180 minus 50.26 gives me my new angle A of 129.74. Now I have two angles, angle C and angle A, so I can take 180 minus both of those to get me my new angle B. And then once I have my angle B, I'm still looking for side B, I can use my ratios to set up to solve for my side B. Okay? So really not too bad. And if I'm saying that's probably the trickiest part of it all, that's really, personally, I don't think that's all that bad. Questions on that? Hallie?
For number 2, you took 180 minus 36, and then the 129.74.
Correct.
And get the 129.74. Where did you get the 36?
The original angle that was given.
Okay.
Yep. So I'm taking it minus A, which is the new A, C, to find my B. Okay, let's look at this word problem down below. It says, reading it through, Ranger Station A, sights of fire in the direction 32 degrees east of north. Well, first of all, I've got north, south, east, and west, just like the compass. Ranger Station B, 10 miles due east of Station A, sights the same fire in a line 48 degrees west of north. Find the distance of each ranger station to the fire. Well, recognizing that this represents Station A and this represents Station B, let's put in anything that I do know. Ranger Station E sights a fire in the direction of 32 degrees east of north. This is north. I want to go east of north. So this is 32 degrees. Ranger Station B, which happens to be 10 miles due east, which is that direction, sights the same fire. But this time, that angle measurement is 48 degrees west of north. So you start at north and you go 48 degrees west of that. So that means to the left. East is to the right when north is due, or north is straight up. Okay, so what I'm looking for is the distance. I'm looking for the sides of these triangles here, assuming that here's my fire then, okay? Here's my blazing fire. So I'm going to call that C. Then I'm going to label each side. That's side A, that's side B, this is side C. Understanding that the side is opposite the angle is how I recognize that. So I'm guessing that one of the first steps I need to do is find these angle measurements here. So how do I find this interior angle A?
Take 90 minus 32.
That's exactly right. 90, because that's a 90-degree angle. If it's due north and due east, all of that, then that's representing a strict angle. So that's 90 minus 32. So this is 58 degrees in this corner. I'll do the same thing for angle B. 90 minus 48 is 42 degrees. And then angle C should be fairly simple to solve. I take 180 minus both of those. And it becomes an 80-degree angle at the top. So what I have now is I have 3 angles. Do I have a side measurement? Which one? C. I have this. This is 10. So my first ratio I'm going to set up is using my C's. So that's going to be the sine of 80 over side C, which is 10. And then I need both sides, A and B. Does it matter which one I use first? Nope. Which ones do you guys want? A? So let's do sine of 58 over side A. Cross multiply, which leaves me with A times sine of 80 equals 10 times the sine of 58. Divided by the sine of 80. A is 8.61 miles. And then I'll do the same thing, exact same thing, solving for B, using my C, sine of 42 over B, cross multiplying, B times the sine of 80 equals 10 times the sine of 42, divided by the sine of 80. B ends up to be 6.71 miles.